Hello friends, today we will discuss a proving on real analysis. This will question that if we have a closed interval and an open interval, we will prove that there does not exist any continuous surjective function which is from closed interval to open interval. It seems like that there exists a continuous function because it is closed and it is open. Because of the closed interval to open interval, it is easy to go, but open interval to closed interval, it is tough. So we will openly say that it is true, but it is not true. There does not exist any continuous surjective function from closed interval to open interval. This is a statement which is in real analysis. Now let us prove it by contradiction method. Assume contradictory that there exists a continuous surjective function. This is a function f. We let that there exists a function from closed interval to open interval, right? If this function exists, then if the function is continuous and surjective, and the surjective function implies that inverse image of functions exist. Inverse image f inverse of x is equals to, what is inverse image? F inverse of x is equals to y is in capital Y, that is it is capital X and it is capital Y. So y is in capital Y such that fx equals to y, right? So then if inverse image exists by surjective map and the function is continuous, so this implies that firstly we take surjective map. So there exists a if we take a sequence xn is in belongs to inverse image of 0 comma 1 by n. Why we take v 1 by n? Because of this is 1 and this is 0. So 1 by n gives the 1 by 2, 1 by 3. Supremum value is 1 and infimum value is 0. So we will take 1 by n as compared to 1, right? Now by Bolzano-Weierstrass theorem we may assume that xn converges to x is in closed interval 0 comma 1. We will have a sequence xn which converges to x. If converges to x which also belongs to 0 comma 1, right? Closed interval 0 comma 1. But by continuity fx, this implies that fx is equals to 0, which is absurd. So this implies that there does not exist any continuous function on closed interval 0 comma 1, right? This always we will say that fx is always 0 because we apply the continuous function